Good morning, guys. Today we're going to be looking at Notes 3.04, and today's topic is going to be about combining reflections and translations. So combining these two types of transformations. There's actually three, right? Because in here we have vertical and horizontal. Order is going to matter when you're applying the functions. Well, we just want to keep in order, kind of to keep things consistent as we bring in new examples and new functions. We just want to keep kind of the steps correctly or like in a certain order. Okay, so first reflections, second horizontal translation, and third vertical translation. And I'll show you how that kind of looks as we look at the examples. So we're going to look at these 5 examples here, and we're going to do the same thing that we've been doing in the previous notes, identifying the type of function that it is, list the table of points, and the graph. Okay, and so let's go ahead and jump to the first example. So in this first example, we have a certain type, and I actually forgot to put what type it is, so let me put it right here. Yep, let's do that. Okay, so this is a quadratic. Because we have the power of 2, and then the key points in a quadratic was 0, 0, 1, 1, and 2, 4. So if I plot those points, it's 0, 0, 1, 1, and 2, 4, and then we kind of create this mirror image. Okay. So we have the following parent function. Oh. Okay. And now we want to break down the equation and figure out, what's happening in the equation. So we should notice that there is a negative in front of, it's outside, it's in front of the equation. So that means that there's a reflection. And it's a reflection over the x-axis. So that means all these points that were up here, they're going to be reflected down this way. So we want to think of the reflection. This is our mirror. The reflection, the mirror is the x-axis. And so every point that was on top is now going to be on the opposite direction in the bottom. So 1, 2, 3, 4. 1, 2, 3, 4. Okay, so these are my new points here. And then we keep looking at the equation because we're not done, right? Because we have x minus 3 inside. So then that means that we have, horizontal translation, and minus 3 means we're going to translate to the right. So every point's going to move 1, 2, 3 units to the right. So right here. And follow this pattern there. And this point's going to go 1, 2, 3. There. Follow over there. And then I'll connect it. So then we have the parent, the original, right? And then we have the transformation. Awesome. And so just remember, if the negative is outside, we're reflecting over the x-axis. And then inside the equation, we know that there's a horizontal translation because the -3 was happening inside. All right, let's go to example 2. In example 2, we're going to state the type. So here it looks like we have a square root. The points on the table would be 0, 0, 1, 1. The square root of 4 is 2. The square root of 9 is 3. So we plot these points. I would plot the following. And I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3 up. Okay, and then we have a reflection. If we look at the equation, but the question is, what type of reflection do we have? You see, we have the negative inside the square root. So this is a reflection over the y-axis. So that means the y-axis is going to be like my mirror. So every point that was on the right side is going to be reflected to the left side. So I'm going to have this point over here, then this point over here, and then going the opposite direction over here would be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3 up. So double check. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes. Awesome. And then this point at 0, 0 is the same point. Okay. So I'm not going to connect it yet because we're still going to continue with the transformations, right? There's something else happening. There's a -5. The question is the -5 inside the square root or is it outside? And you would say, it's outside, right? And since it's outside, that tells us that we have a vertical translation. And what I'm going to put is the following. I'm just going to put VT. VT would be vertical translation, and I'm going to be moving down 5 units. So all these pink points, I'm going to move them down 5 units. So it's 1, 2, 3, 4, 5. And I'll put my red dot there. Then I'm going to do 1, 2, 3, 4, 5. Put my red dot there. 1, 2, 3, 4, 5. Okay, and then I'm going to connect it. So here I would connect this way. Something like that. There we go. Awesome. So we have the parent, and we have the transformation. All right, let's go to the next example. In this next example, we have a cubic. And so the points for cubic is -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. So that's 0, 0, 1, 1, -1, -1, 2, 8, be 1, 2, 3, 4, 5, 6, 7, 8. go in the opposite direction. 1, 2, 3, 4, 5, 6, 7, 8. All right, and then let's look at the equation, see what's going on over here. So over here, I see right off the bat there's a negative in front. The negative is not inside the parentheses, it's outside. So since it's outside, it's going to reflect on the x-axis. So the x-axis is going to be my mirror again. This is like my mirror. And so basically, all the points are going to be in the opposite direction. So this point that was up here is going to be down there. This point that was down there is going to be up here. So everything's going to flip. Everything's going to switch. Okay, so let's plot these. If I go in the opposite direction, it'd be 1, 2, 3, 4, 5, 6. Actually, I can just do that. There we go. Yeah, what I was looking at, what I was doing is, what I can actually do is, since this point, for example, is going to go up here, it's basically opposite this point right there, the same space. And the same thing over here, this point that was here is going to go down here, and it's just directly opposite to this point. Okay, and then we got to continue. Before we connect the dots, I always like to kind of finish all the movements and all the transformation that's happening. So we have x plus 2. X plus 2 is inside. So that means we have a horizontal. I'm just going to put HT translation. And it's plus 2, so the opposite would be to the left. And then we have this plus 1 outside here. This is a vertical translation, and it's going up. So we're going to go to the left 2 and up 1. To the left 2 and up 1. Left 2, up 1. We're going to have this pattern, following the pattern that's already there, right? These 3 diagonal points. And then this last point over here, we're going to move it to the left 2 and up 1. All right. So the blue one is the parent and the red one is the transformation. Let's go to example 4. Let's see what type we have. Here we have a cube. Pick a different color. Here we have a cube. Cube roots. And so these points are the exact opposite of the cubic, and so it's going to be -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. And I know I said opposite. I actually mean, we're just going to swap the x's and the y's. So that's going to give us a parent function that looks like this. Drawing over here on the grid, we're going to go 8 this way and 8 this way. So we're going to do 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 2, 3, 4, 5, All right, now let's look at the equation and see what's happening there. Right, we should notice that there's a negative inside the parentheses, so that's a reflection on the y-axis. And this plus 6 is outside of the square root, so this is a vertical translation. So I'm going to put, again, VT, and it's going up. Vertical translation up. So let's do the reflection first, and this time it's going to be on the y-axis. So that means every point that was on the right will go to the left, and every point that was on the left will switch over to the right. So that would give me a graph that looks something like this. This point in the middle there. And then we're going to move all these points up 6. So I'm going to start, let's check what we do. I'm going to start by moving the middle one up 6. So if I do that, it's going to be 1, 2, 3, 4, 5, 6. So that's going to be right here. And then I'm going to follow the pattern that's there. We have this kind of 3 diagonal points, right? Then I'm going to move these. The far left one, it's going to be 1, 2, 3, 4, 5, 6. Here. So I want to make sure you're keeping track. So I'm just moving this point here, this pink one, up 6 units. And then I'm going to move this point up 6 units. The one on the far right. So that's going to be 1, 2, 3, 4, 5, 6. Up here. There we go. And then connecting these. Awesome. And again, feel free to pause the videos as you feel needed. I mean, you could do that at any point, anytime. And let's look at the last example, example 5. Here we have, also keep in mind, I know some students were saying, oh, I thought this was like a -1, but it's an absolute value. And so that's what I'm going to put here. The type that we're working with here is absolute value. That means we're going to use the points -1, 1, 0, 0, and 1, 1. And just remember what shape it has. If it's absolute value, it has a V shape. V shape. So let me get my ruler. Nope, I don't like the way that came out. Let's try again. That one was a little bit better. So that's my first diagonal. And it's funny, right? I can draw these cubic functions really good, but when I'm drawing straight lines, that's when I have the most trouble. Great. All right. Let's see what's happening with the function. Then we see that there's a negative, a -4, and a +7. So there's 3 transformations happening. And notice, the pattern or the steps that we're doing is that we're reflecting first, then we're doing the translations. And if we follow the translation order, right, because we read from left to right, so we see that there's a reflection, a horizontal translation, and then a vertical translation. So we have a reflection. Now, is this reflection over the x or over the y? You know, is the negative inside the absolute value symbol, or is it outside? And you would say, you know, it's outside, so it's going to reflect on the x-axis. All right, so if I do that, let me draw this dashed line to remind me that this is going to be my mirror. And so I'm just going to reflect the points here and here. And then we're gonna translate it, and we see that there's an x minus 4. So that means that this is a horizontal translation to it's minus 4, so it's to the right. I'm gonna do lowercase to the right. And then the plus 7 is a vertical translation up 7 units. Okay, so I'm going to move these points. I guess I'll just start off with moving the center point 4 to the right and 7 up. So 4 to the right, 1, 2, 3, 4, and 7 up. 1, 2, 3, 4, 5, 6, 7. And I'm just going to copy these points here because they're going to create, you know, a V formation anyways. And then I'm going to grab my ruler and make this downward V shape. And then I connect the other 2 points over here. All right. And I know what you're probably thinking is, you know, why didn't I draw this, extend this out a little bit more? It's fine, as long as I know that the V shape's opening downwards, the arrows are pointing downwards, and I move the points the correct distance to the right and up. All right, so that brings us to the end of our notes. I'll see you guys next time in class. Again, if you have any questions, if you want to clarify anything that I did in the videos, let me know during the class time, and we can clarify anything at that point. All right, have a great rest of your day, and thank you for joining me today. See you guys next class.